Without further delay, I'd like to introduce today's presenter, Michelle LaRue Bustamante, Chief Architect for iDesign Inc. Michelle, you now have the floor.
Thank you very much. Welcome, everybody. So today we're going to be completing our 15th webcast on WCF. And so if you have missed any of the others, then just remember that you can go to my weblog and you'll be able to find out a list of all of the previous recordings that we've done. Today's topic is extensibility. So this is a fairly advanced topic, obviously, related to WCF. So I'll be describing a couple of things in a few minutes and give you an idea of what we're going to be talking about. And again, just some background on myself. I do work with iDesign Inc. I'm a chief architect there, and I'm also a Microsoft Regional Director for San Diego. I finished a book called Learning WCF just this spring that passed, and all of the code for the book has been posted to thatindigogirl.com. So at this website that you see down here, that's where you're going to go to get the code samples for all of the webcasts we've done so far. Today's webcast, however, since it's related to extensibility, I have some additional samples that I will be posting to that weblog after the webcast today. So just keeping that in mind. And then also I have another weblog, duffblonde.net, where I post other information not specifically for the book. It could be other topics like card space and so forth. So today what we're going to cover is extensibility features of WCF. I'm going to talk about a few things. So you can probably imagine that each extensibility feature is fairly in-depth. So I'm going to take it from a beginning standpoint. What are some basic things everybody should be able to do? And then I'll go to the more difficult aspect, which is custom binding elements and channels. But starting with just the basics, we'll talk about customizing service host initialization, how we can override that, how we can add custom behaviors at the service level, possibly to endpoints or contracts or operations, and I'll explain the difference between those. We're going to talk about how we can intercept messages, inspect those messages, inspect parameters. We're going to talk about how we can provide a context for each operation, as it's called, so that you can flow that between services and clients. And then finally, we'll talk about custom binding elements and channels. So the level of the webcast today is 200. It does require, however, that you have a pretty good knowledge of WCF client services and binding configurations. So some of this may be a bit advanced, like I mentioned, and you might want to go back and revisit some of the earlier webcasts. So just sort of in order what I'll do, I'm going to talk about Service Host and Service Host Factory first. Then we'll talk about behavior extensions, message interception techniques, how to do custom extensions and context, and then channels. So starting with Service Host. Service Host is, as you know, responsible for the initialization of the channel at service. So when you provide inputs to your Service Host, what you're doing is saying, these are the channel listeners that I need to listen to requests incoming. And without really extending the service host in depth using a factory and so forth, you can actually add behaviors, customize behaviors. You can add error handlers, but that does require overriding the service host. I'll show you that. You can hook any sort of relevant events related to the service host. For example, when there's been a fault at the service host, you would want to know about that because that implies that you need to restart the service host to listen for messages again. And then we've got things like extending the service host in order to override how you produce a service description. For example, how do I produce the WSDL document? I might want to control how that works. I might want to add documentation features and so forth. And I might also want to override initialization, for example, to hook error handlers. Now, aside from service host, there's also a service host factory. And the factory is responsible for creating the appropriate service host when we host in IIS or Windows Activation Service. So in other words, in a self-hosting environment, what we do is we write code to create the service host and open it. And that will open a channel listener for each of the endpoints provided. And that applies to console, Windows applications, and Windows services. When we think about hosting in IIS and WAS, we actually provide a service host as well, but we do that using a declaration, an @service host directive. And you may remember this from my hosting webcast early on. So we provide this .service endpoint, and inside the .service endpoint is an @service directive that says, here's the type I want you to create for requests that come into the service host endpoint. Now, in IIS and WAS, if I want to override how that service host gets created to insert behaviors that I want to be controlled at deployment in the configuration, then I will need to override by providing a service host factory. So without any delay, what I'm going to do is start by demonstrating some of those features that I just talked about. So let me hop over here to my desktop, and I'm going to open up a demonstration. And so here we have a service host extension demonstration. And I'm going to start by reviewing what we have going on. So first of all, of course, I have a service called Messaging Service. And that service has a single operation, send message. So nothing really going on there at this point. We're hosting the service inside a host. So if we actually take a look at the self-hosting environment, right now what we've got is just standard initialization. I initialize the service host, I open the channels, and the channels are, of course, channel listeners are, of course, at whatever endpoints I provide. So here's my one endpoint at this point. Now, when the client consumes that service, so let's take a look at the client code, all it does is create a proxy, decide which endpoint we're hitting. We're hitting the self-hosted at this point. And then at some point, we start calling the service. So nothing much going on there either. Let's just give it a run, and I'll show you what happens by default, and then we'll make some changes. And so I'm going to hop over to the client and the console. There's my self-hosting console. I'll make a call, and you see the messages get through. Really pretty simple. Now, what I'm going to do is to illustrate a point in terms of extensibility, I'm actually going to add some overrides to the service host. So starting with, in here, let's say I wanted to customize some behaviors. So I can look at the service host, and you can see here I have access to the authorization settings. So if I wanted to customize in code or hard code a certain way that we do authorization so that it can't be configured by the configuration or administrators of the machine. I can modify and access the channel dispatchers, which actually relates to each of the endpoints and the channel listeners that we have available. I can access credentials. I can access the description. I can certainly override events like opening and opened, and more importantly, fault, which is above here a bit. If it faults, we can override that event. And that's actually a good one to provide a handler for so that you can notify an administrator when something happens. And then a couple other things that I might want to do. I might want to go to the description and access things like the behaviors. So let's give an example. What if I wanted to make sure that if you have not yet provided a throttling behavior, that I provide the default in the hosting environment that makes sense for us? So I might go ahead and do a find looking for service throttle behavior. And what that will do is return to me an instance of the service throttling behavior if it exists. So I can check if throttle is null, then I want to provide some good defaults. So let's say I'm going to say throttle equals new service throttle behavior. And I'm going to set some throttling settings. You might have remembered this from the webcast I did on concurrency and throttling. So I can set the max concurrent calls, let's say to 30. It's usually defaulting to 16. I can set the max concurrent instances to 30. If I'm doing per call services, these will be about equivalent. And lastly, I can set the max concurrent sessions to, let's say, 1,000. Let's say I have, some percentage of users I expect to be online, and I want to make sure I can construct at least 1,000 sessions for this particular. Now, what is a session? Again, we talked about that in an earlier webcast. It could be a transport session like TCP, or it could be named types, or it could be actually a session related to reliable sessions or security. And it also could be a session related to application sessions. So remember to go back and look at that webcast again. The point here is that I'm creating a new throttling setting, and I'm going to go ahead and add that to the host description, behaviors add. And we can add this throttle. And now I will have a default set of, instead of using the defaults, I'll have a different set of behaviors that I'm working with. Now, we're not going to test this and go through all the throttling and testing of that. What I wanted to do is illustrate that this is one way to extend the service host, of course, hooking exceptions, adding behaviors, and I might not code this right here. I might want to actually create some way to sort of encapsulate common behaviors in a base class, actually. In fact, on iDesign, we have a service host X or service host T, which is a generic type that will allow you to do a whole number of things like putting in debug behaviors, metadata behaviors, and so forth. You might want to take a look at that as well. Now, let's go into an extension and say another way that we can extend the service host, and that is to actually derive from service host and override some of the functionality. We kind of have to do this if we want to do things like add service error handlers, because you have to do it before initialize runtime has completed, or after you've initialized the runtime, but before we open the channel dispatchers. So in other words, I can't write the code here, because what will happen is host open won't respect the error handler unless I add it after initialization and before open. So we have to override service host. And what I would do in here is basically say for each and iterate through the channel dispatchers. So we'll say D equals, in this channel dispatchers. So for each of the channel dispatchers, which is for each endpoint I'm exposing for this service, what I'm going to do is say I want to add an error handler. And I'm going to add a custom error handler that I've pre-created. So I'm calling it fault error handler. And we'll create an instance of that. And now I'm going to have an error handler for each of my endpoints. The error handler is actually up here, and I talked about that in our exceptions and faults webcast. So I won't go into the details of how to create an error handler right now. What I'll do instead is just remind you briefly that it's a type that implements iErrorHandler. And in here we've got some code happening when we handle errors, and we've got some code happening to provide faults if we haven't got one. And I'll talk about that in a moment when we hit the breakpoints. So coming back to service host then, what I've done here is I've made it possible to add, encapsulate adding an error handler for every service that uses my custom service host, okay? And so I'm going to go back to the place where we initialize service host and call this service host X. So now I'm using my custom service host, which will override, and when we call open, it will call initialize first, and then it will create or add the error handlers. Now, of course, to see the error handler in action, we're going to need to cause an error. So what I'm going to do is add a problem by throwing an exception here. And let's go ahead and give it a run. So there is my console. We're going to send a message. It's going to cause a problem. We will throw this exception. And it looks like my error handler has been successfully configured. We're checking to see if there's been a fault or not. And if not, we're creating a receiver fault which provides information to the client but does not fault the channel so we don't lose the session, which allows us to continue to reuse the proxy at the client. And then, of course, if there was an exception thrown, instead of a fault, what we're going to do is notify the administrator. In this case, I do that by writing to the console. So to review, what I just did is added an error handler And with that error handler, what we did is we caught exceptions and turned them into false so that we wouldn't break the channel. Now, that doesn't mean that's the only type of error handler to create. In fact, there's a couple of different models you might approach for that, but those you'll want to listen to my previous webcast for the details. Now let's talk about what happens when I host with IIS or WAS. Normally you see something like this, where I supply a service type and it will construct the service host for me. Now the problem is, how do I use service host X, my custom service host, in order to add that error handler that we've just created? The way to do that is to provide a factory. So we're going to go ahead and provide the service host factory X that I have created. And I've put that into a DLL called Common Extensions, Service Host Factory X. And that's that. Now, what is Service Host Factory? Well, we have to implement it. So what I'm going to do is actually stop debugging here. And so what we're going to do is override Service Host Factory. And the overrides that we're going to provide are basically the process of creating the service host. And instead of returning what the default would have been, which is to create a service host, we're going to return new service host X. And service host X will take the service type and the base addresses provided, and now we'll be using our service host when I host in IIS. So I've got this service, which will now use service host factory X, and in the web config, it's still going to be the same service model section. So I've got this service already configured. And so what I need to do is actually just update the client so that it uses the web host endpoint, which I've already configured. So what I'll do is modify the client code, change this from self-host to web host, and we will test whether or not exceptions work through the web host. And so I'll give it a run. Actually, that's probably happening because one is not alive yet or something's wrong with the service. So let's just go ahead and run this in the browser first. My port has changed. There's a way to make it so that that doesn't happen, but obviously I didn't do it in this example. So I'm going to actually have to just update the endpoint for the client, and then I'll run the client. So let's go ahead and take a look at that app config. And the port is clearly different. So we'll go ahead and run it again. So here's my client. Now it's going to hit the web host. A problem occurred, of course, because we threw an exception. And it looks like my error handler is engaged. So that's how you extend service host for IIS environments. And one example of things you might want to do when you extend the service host is to add error handlers and possibly override default behaviors. Now, the question you have to ask yourself is whether or not you want to do that in the service host or whether or not you would rather actually have behavior overrides tied to the actual code. So this is an important question because as this slide illustrates, there are other ways to apply customized behavior extensions. Okay, so you don't actually need to use the service host to customize behaviors in all cases. What we can do is decide if we would like, we can first of all create custom behaviors that are applied to the service as a whole or just to a particular endpoint or just to a particular contract that we implement. or we can apply it on an operation level. So you can decide if behaviors apply to those different things by creating, again, you might have custom behaviors that you would like to create, and I'll show you some examples. And you decide whether the scope of the behavior is global to the service, particular endpoint, contract, or operation. How you do that is by creating a type that implements one of these interfaces, or possibly several of them if you would like. And you can add a derivation to attribute in order to apply these declaratively on the service, the contract, the operation, and so forth. And so that would be another way to modify the way the dispatching of messages happens instead of going to the service host, for example. Now, all of these behavior extensions, each of those interfaces actually have some things in common. They have overrides for adding binding parameters. So that would actually give you an opportunity to, early in the life cycle of the service host, before it opens all of the channel listeners, maybe you modify the bindings right there and set some defaults that you prefer to use and so forth. You can also validate a binding and say, look, for this contract, I require that the binding is secure. So I want to make sure that you have certain settings. And if you don't have those settings, we're not going to load the service host. So you can validate the binding. An example of that that's built into WCF is when you use the protection level property on the operation attribute. So another thing you can do is apply dispatch behavior and apply client behavior. The two are different in the sense that apply dispatch behavior has to do with what we just did with the error handler. You saw me basically, after initializing the service host, modifying the dispatch behavior by editing a channel dispatcher and adding an error handler. That's an example of a modification. Other modifications would be the throttling behavior that I modified. Other examples could be you have custom behaviors you'd like to insert into the mix. So this is your opportunity to do that. Now on the client side, we have proxies, and proxies also may need to apply the same behavior or a behavior. And in order to do that, it overrides apply client behavior instead. So iService behavior is the only interface of the previous that I listed here that does not implement apply client behavior, of course, because it's not a client thing. Services are services. Okay, so the summary of this is basically that we can extend the environment with behaviors. We can implement behaviors that apply to the service, the contract, the endpoint, or the operation. And behaviors may be things that we need to use on both the client and service because they need to be compatible, because you might create a custom behavior that inserts functionality that has to match on both sides, or you might just have a behavior that affects one side or the other. So let's take a look at an example of how we create a custom behavior extension, and we'll go on with that. Now, what I'm going to do is actually use the error handler for now as my example for this. And so if we take a look at what I did before, obviously we were using a custom service host, X, in order to initialize the environment. So what I'm going to do instead is we'll actually go ahead and stop debugging. And we'll forget about this custom service host here. But what we are going to do is we're going to go to our service and we're going to apply an attribute that is a service level behavior. And this attribute is going to be fault error handler. So what I want to achieve is that I want the fault error handler to be applied to this service. That means all endpoints to this service. So what we're going to do is take a look at the custom error handler that I created. This is what we would like to apply. How do we do that? Well, I can create an attribute that implements iService behavior. And iService behavior has a function for add binding parameters, We're not going to override that, though, because this is not related to bindings. We do want to override apply dispatch behavior, however. And what we're going to do is the same code you saw before. Iterate through the service host dispatchers and add the fault error handler. And I should probably add a to-do in here that says only apply to non-MEX endpoints, because we probably don't need the error handler on our metadata exchange endpoint. We might want it to be there, but we don't need it to be there necessarily. So I might check which dispatcher we're looking at. And then the other thing we can do is validate. And so again, we're not overriding that in this particular case, but what I might do here is look at the service description and compare that to what the current endpoint's doing and which bindings were configured, and if I don't like what I see, I can throw an exception. So all of that is right here in my fault error handler attribute. So let's go ahead and take a look at the host, the messaging service. Now right now I don't have a reference to my library that has the extension in it, so let's go ahead and add a reference to common extensions. And now my fault error handler is available. And so with this attribute, my error handler should still engage, even though I'm no longer using the custom service host base. Let's see what happens. So there's my console. Well, actually, we're not hitting the console, are we? So let me rerun this because I probably need to change the client back. And the client actually, again, we're just going to go back to self-host, which means we'll hit the console host instead. So there's my console, there's my client. We make a call. An exception will occur. We will catch it because the fault was configured. And that's that. Now, why was it configured? Because the apply dispatch behavior override worked. So there we go. So let's continue. Now, as for the other examples, I endpoint behavior, I contract behavior, I operation behavior, you're going to see a few more of those actually as I go through some other demonstrations. So I'm just going to continue on with some other examples of interception. And what's going to happen is we're going to need to rely on the behavior overrides to inject other types of extensions to the environment. So to rephrase, you override the service host. What you're doing is you're saying, when I host the service, I'm going to decide what behaviors I want to add. When you apply an attribute to the service or to the contract or to the operation, then what you're saying is, I want to declaratively make sure I always associate this behavior, for example, injecting the error handler, and I don't want administrators or people that host the service to control that. And now we're going to talk about, well, what are the types of things I need to have a behavior for? I showed you error handler, but there's all kinds of other custom extensions that you might need to inject. For example, on this page, you can see we're talking about message interception. And types of things you might want to do, for example, could be inspect parameters for validity, to make sure that parameters fall within a range, to validate against a schema. You might also want to inspect the whole message. So there's things called client and dispatch message inspectors, which allow you to inspect and modify messages on either end, either on the outgoing message from the client or on the incoming and return message from the service. And that allows you to look at the entire SOAP message, check for values in there, validate against a schema if you wish. Usually that is a bit of overhead, which is why it doesn't happen by default. And you might want to do custom validation so that you don't use a schema. Instead, do some custom validation only on the things you care about. And you want to centralize that to make it reusable so that you're not baking that code into the actual type. We don't want to waste time deserializing if the message is already known to be bad. So it saves time. Now, the other thing you might want to do, and this is very much more advanced, and that is to have a client message formatter or a dispatch formatter. What that means is you're basically replacing the data contract serializer and using a custom serialization mechanism, which means you control how to make your objects into XML and vice versa. Now you might think, well, there's probably very rare cases that I need that. And you're right, it is a rare case. However, I can give you an example of one customer that I was working with recently that wants to do some very custom binary serialization of all of his objects. And the reason why is not relevant to this discussion, but the point is this is the perfect place to do that work. So it's a great type of extension that's available to make it more elegant. Otherwise, what you end up doing is not using data contracts at all, and you end up sort of bypassing a lot of WCF natural behaviors. So parameter inspection, message inspection, and complete overriding of the serialization process are examples of things you can do. And to give you some context on how to inject these things, I'll show you in the code sample I'm going to demonstrate. You also have other things like operation selector, which is, again, one of those things you won't need to use too often, but if you have some sort of router, you might need to, when messages come in for a particular operation, redirect it to a different operation based on whatever's in the message. Maybe you provide some sort of catch-all method that forwards to appropriate methods on the fly. Or maybe because of backward compatibility with old clients, you want to modify the message when it arrives and move it to a different operation. So there are things you can do to override that. This is a bit, again, not as common, but operation selector is one example and operation invoker is another. Now, to get you some visual on what I've done here, let's actually go to an example. So I'm going to stop debugging this particular last demo. And what we'll do is go to a new example. And what I'm going to do here is actually demonstrate parameter inspector. And what this will illustrate is a number of things, because we're going to have to create the parameter inspector, and then we're going to have to apply it with an attribute. So let's go ahead and first of all take a look at what we've got. What we've got is a client sending messages, the same as the last example. And I'm going to add a new item or a new class, and I'm going to call it require parameters. Okay, and in here what I'm going to do is create a class with an inspector. And the parameter inspector uses system model dispatcher, service model dispatcher. What I'll do is implement this interface. And what you'll see is I have an opportunity to inspect the returns after the call, and I have an opportunity to inspect parameters on the incoming call as well. Now, what I can do without getting into the details of the operation description is just for each, I'm actually going to do this slightly differently for a reason, and you'll see that when I get there. For int I equals 0, I less than inputs length, and lastly I increment. And what I'm going to do here is say if inputs I is null, throw new fault exception, and fault exception is coming from a different namespace. Parameter missing. Now, which parameter? I actually don't know unless I have access to the service description, so I'll add that in a moment. But you get the idea, right? I can actually throw an exception when I see that any parameter is null, if I want to avoid any null parameters. So what we'll do here is I'll create an attribute so that I can apply this behavior. So basically what I need is for the parameter inspector to actually be added somehow to the dispatcher. So here's what I'm going to do. Public class, require parameters, attribute, and we'll inherit attributes so that we can declaratively apply it. And I'm going to implement operation behavior. So the operation behavior I will implement. Let's go ahead and create a class frame here. And we'll implement operation behavior, which, as you can see, I have an operation behavior. I have an opportunity to, based on the operation, add binding parameters. Based on the operation, apply client behavior. That's if we were using this on a proxy to inspect outgoing parameters and incoming responses. And then apply dispatch, which is what I want, and then validate. And this is not validate to be confused with validating the parameter. It's validate in terms of this dispatch behavior. So what I'm going to do here is I'm going to say, again, for each channel dispatcher in, oh, actually, I'm sorry. I actually have access to the dispatch operation directly here. And what we'll do is add a parameter inspector. New, required parameter inspector. Now what I want to do is actually provide more information to the parameter inspector. So what I could do is pass the operation description here. And that would be nice. So that will give me more ability to detect what the parameter name is that failed and so forth. So what I'm going to do here is add a constructor that takes that override, or that provides that information. So operation description. And what we'll do is create a property to hold that. So we'll call this description. And then we'll go ahead and set it. So the constructor will provide that information, and guess what? I can use that in here, because now I can say string.format, parameter is missing, which one? And which one is going to be description. And we'll get access here to the messages. Now I know this is the incoming message, so actually what I want is the incoming message description and the body and the parts. And what I want is the part in order, of course, of appearance. So I'm going to go with part I and give it a name. And so now I'm going to be able to throw a fault saying which parameter was null that I found. Okay, so we've now completed a require parameters inspector, and we've created an attribute that we can apply to an operation that says require parameters attribute. And now we can go to our service and we can say, hey, I want to require parameters here. And now, of course, I'm sending a correct parameter when I pass a string. And if the string is null, I'm going to say, no, that's bad. So let's go ahead and run it. Oh, sorry, forgot one thing. You return a value here if you want to attach a context that would then be provided here in the correlation state for after call in case you're doing something on both ends. So on the service host, we're applying the dispatch behavior. And so we know that that operation inspector is there. And now we're going to get the call. The inputs are that I have a single string called message 0. So it's not going to fail. Good. Now let's make it fail. Well, how do we do that? Well, imagine I update a service and I have several parameters, like let's add a date time value, and that'll be param, or let's call it unknown param. And what we'll do is we'll modify the service implementation to reflect that. And let's run it again. We add the dispatch behavior. We call the service. My inputs are a null and message 0. Why? Because the message from the client doesn't include that element in the body, but because the service operation description requires it, it gets initialized to null at this point. Of course, a date time would then get converted from null to some default value. So what's going to happen here is we're going to throw a false, but we're going to get access to the body part name. So the body parts are here. It shows information about those body parts. You can see the name is unknown param, and that means my message will display that. Parameter missing. One thing that you kind of have to remember to do with the format string, of course, is parameter missing which one, right? So if I run it one more time, we'll see that. So we'll call send message, exception will happen, parameter missing, unknown param. Okay, so you can see that there's a lot of potential power to that, some things that you can do. I've shown you here how to do a couple things, like use an iOperation parameter that applies to an operation, and I've shown you how to create a custom parameter inspector and some of the things we can do with that. I'm going to show you a message inspector in the next demo. And I'll also be talking about some other things in that demo, so let's review quickly. There are some other extensions that we can do. We can actually create these things called extensible objects, and you can extend the instance context for the client channel. You can extend the operation context for the service channel. You can extend the service host. And what that means is that you implement I extension T, where T is one of those types. And then what that does is gives you the ability to modify that type during the request or as the runtime is loaded. And then you can add features to it. So the best way to really illustrate that is with the demo. Let's go back to the code. And I'll stop debugging. Well, actually, I'm not debugging anymore, so that's good. I have an example called instance context. And in this example, I'm going to actually show you the service code and what I'm looking for here. What I'm looking for is a way to flow a custom business context. What I want to do is I want to have access to inside the operation context. I want to have access to the culture of the user who called from the client. I want to be able to flow that information from service to service. I also maybe want to have some things that are not related to the current thread like culture is. Instead, I also want to carry other information in the business context like a partner identifier or something like that. Maybe profile for the user. Just basic information I want to pass around that we normally don't have another place to attach it to. With culture, we can always attach it to the current thread so that the current thread always reflects the user's preferred culture. And we should do that anyway. But when you talk about custom information like profiles and partner identifiers, that information doesn't have a place to go. So putting it in the operation context gives us a way to always get at it. Now, the syntax for getting it is to get your custom extension. So that means I have to implement a type that can extend the operation context. And that type is shown here. It's an extension of operation context. And you provide whatever storage you want for that, which in my case is a business context info object. And that contains the culture and the partner ID. There we are, 2 properties. And it's serializable. It's a data contract, which means I can flow it in a message header, can't I? Now, what I'm going to do in the context extension, essentially all you want to do is make sure you can always get at the current extension easily through the operation context. So operation context find will return me the current business context info. And then that would save me some time so that I don't have to write out the entire thing here every time, which is a bit long. Okay, so that's the goal I have on the server side. On the client side, my goal would be to do something like this. When I use my proxy, I want to be able to just add some context that will automatically flow across to the server. So we can do that by adding a behavior at the client. So I probably forgot to show you that at the service, I'm applying this as a behavior declaratively. Remember, behaviors can be added at the service host programmatically, declaratively, as you're seeing here, or even in configuration file if you like. Same thing goes for the client side, but in this case, instead of using a declaration on the contract, I'm showing you a way to programmatically add a behavior on the proxy. So I'm adding a behavior on the proxy that says, hey, I want to add this client behavior. And if we take a look at the behavior, the client behavior, you'll see that it's an attribute as well, so I could have done it declaratively. It's an endpoint behavior, which means I can declaratively apply that to the endpoint of the client. And then this is the client message inspector. So there's a new interface for you to look at here, where we are in the message inspector going to, before we send a request, take the information in the business context and add it to the request headers. On the server side, we've got a dispatch behavior, which is implementing iDispatch message inspector, which means after we receive a request, we want to add the business context to the running context. We want to then find the header from the message that came in. If it's not there, it's a problem. If it is there, we're going to initialize that business context so that the operation context always has my information from the header, which is the culture of the user and the partner ID. But because we're dealing with culture, it's also important to set the current UI culture and culture for the thread, because all of your built-in .NET components, your assemblies downstream that are not WCF services, for example, may have code that basically automatically reacts to the current thread and its culture settings. So it's always important to also set that here. Just like with security, we set the security context for WCF, but we also set the principle of the thread, right? Because these are built-in .NET things. So what's going to happen here is the client is going to send a header, the service is going to receive the header, and it's going to initialize the context and the culture of the thread. I'm just going to run it, and then we'll walk through the process here. So on the client side, we have added a behavior manually. We have said, this is my partner ID, and this is my current UI culture, the name of the culture. And we open the proxy, it creates the channel, and then basically as we make a call, it's going to invoke. Now notice I'm getting a breakpoint here as I open the proxy that says apply client behavior. This is the I endpoint behavior implementation that says, look, I want to add a message inspector to the context. So I've got access to the client runtime object. I'm going to add a message inspector. And the message inspector is my client business context. And so we hit go. Now on the server side, we get to apply a dispatch behavior. Why? Because we have a message inspector we want to add, and we made that a service behavior. So we get an opportunity to iterate through the channel dispatchers once again. This time, instead of error handlers, we're looking at the message inspectors for each endpoint. We might not want to do it for MEX, so I just put a to-do here, keeping the code simple for our discussion right now. So we got this message inspector, we add it, and now it's going to be ready to go. Now, of course, it took too long, so we'll hit those breakpoints a little faster this time. And we go, and we go, and we apply the client behavior. And now here's my service running. Here's my client. Let's send a message. Before we send the request, look what happens. My message inspector hooks in. I get to modify this message. Notice it's a ref. If I want to change the message, like for example here, I'm adding headers. So I'm calling create message header with my business context, which basically goes in and says, hey, create a header and use this namespace. So I've actually got a couple of utility things going on here, some constants for the namespace of the header and for the name of the header. We create the header for the outgoing message, and away we go. Now on the server side, I receive the request. I can also modify the message here before it goes to the operation. That's another thing message inspectors can do. But in this case, what I'm going to do is I'm going to do a couple of things. I'm going to create that operation context extension. I'm going to find the header that was sent, make sure it's there. I'm going to set the properties of that business context to include the values of the header. I'm going to set the current thread with the correct culture setting because I want to make sure the .NET stuff works as well as the WCF stuff. So now what happens? My service dumps out the values. Isn't that cool? So you've seen a lot of stuff there, how to use an endpoint behavior and a service behavior to inject custom message inspectors so that I can look at the message on the way out, add headers, receive the message on the way in, inspect the headers. This can go both ways if you like. It's a way to pass data that's not related to the actual operation I'm calling. This is context. And then I was able to add to the operation context using an extension to the operation context. So I was able to basically, again, in order to dump that information, you may remember that we have a call here to talk to the operation context and find my extension to the context. So I can get that information anywhere in the lifetime of this operation request. Guess what? If I wrote some code in here to call another service, then that operation context would be available and I could serialize that context into headers to call the next service down the chain. So I can flow that context from service to service down behind the firewall, for example. Let's say I needed to pass the user profile so that workflows always have access to the current context. So this is a way to do that. Now, you may be wondering in all of this mess, how do you keep track of, which thing to use and the order that they get executed? And I actually have this extensibility tracing demo that I keep adding to, but I'm going to run it once just so you can see a little something. Basically what I've done in here is I'm running a client and a service in a console, and look what I've got in this service. You can see that at the very beginning, the first thing that happens on the service side is we open the service host, create the description, apply configuration. These are things we could override. So it's just telling you when would the override happen? When would my code get called in my custom extension? So I've got a custom service host extension in here, a custom binding extension. I'll talk about that in a second. And then I've got a trace service host so you can see what happens in the service host as we open. It calls initialize runtime after checking the binding elements. And then it has a point down here where it calls all my behaviors. I've got a behavior of all kinds here, and I'm tracing the events of those behaviors. And notice it calls validate on the service and then the contract and then the 3 operation behaviors in a row. So for each operation. And then it calls add binding parameters for each of those. So add binding parameters for the service, for the contract, for all the operation behaviors. So remember those methods that we can implement for all the different various I service, I contract, I operation, and I endpoint behaviors? Those are all being invoked in order once when we initialize the runtime environment. That's your chance to do that. And then we build the channel listeners for each of the endpoints. And then at some point, we get to apply a dispatch behavior right before is opened is complete. Remember how I said we had to change the dispatch behavior before we open the channel. So apply dispatch behavior are the things that I've been showing you in terms of override. Now the service host is open, and when we call an operation, guess what gets invoked? I've got a custom operation selector, so it selects the operation first, a message inspector, where we can modify the message, an operation selector again for the next call. We can then override invoking, how we actually invoke an operation. Those are some of the lower level things. But it's just showing you the order of things in terms of if I needed to hook an extensibility point, where would I go? And then at some point down here, we call the operation. So operation invoker calls the operation. After the call comes back, we get to inspect parameters again on the way back. And then we've got, before send reply on the message inspector and so on. A select operation means a new operation just came in. Now on the client side, I installed an endpoint behavior, and you can see that on the client side, it calls validate, add binding parameters, and then apply client behavior before we open the proxy. And then the message inspector for each call I make gets called to interact with the message. So this is just a tracing example that illustrates some of those different extensibility points, like, for example, the operation selector. This is an operation selector, which basically allows me to decide what's the name of the method that you're going to invoke. This is the client operation selector. I actually have a dispatch operation selector that does it slightly differently because I need to look at the message header action and grab the name of the method before I can return it. So you'll take a look at this example. It's just an extensibility example that shows you some tracing logic. But one of the things that I'd like to illustrate here is the way I invoked these tracing objects. So actually, let's take a look at the host environment and the config file. And what you'll see is that I've actually got a custom binding element in here. And that custom binding element essentially could become a full-blown channel that does custom work on the message. So remember that when you build a custom binding, you select a transport channel and a message encoder, and then you add possibly security and any number of other features in here. Well, if you wanted to create, let's say, a channel that does some sort of manipulation on the messages in and out, aside from the message inspectors and things I've already shown you, where it's an actual channel that wraps up a bunch of functionality, like the chunking channel that is so popular for sending large messages, that would be implemented with a custom binding element. This is a custom binding element here that knows how to hook into the runtime and actually install a custom channel. And the way we do that is we configure it with a custom binding element extension. So we have to actually let the service model know that this custom element name is a valid name and say which type do we create. So look at this. This is an actual type that I implement called trace element extension. And I think we got it in here where I have this trace binding element, and then I have this extension element that implements or extends binding element extension element. That's what we do there. And all it wants to do is say, hey, what's the type I should be creating for this binding to do some work? And here is me creating that type, the trace binding. What's a binding? Well, it's an extension of binding element. And if I expand this, you'll see that the things I'm supposed to do in here, besides clone and get property, is build the channel factory. This is an opportunity to change how you build the whole channel stack. For example, in this case, on the client side, I'm building a new trace channel, which, again, I could control all kinds of things in here because I'm responsible for exactly how we build the channel factory. And I can also build a channel listener. I don't have that one hooked up in here in this example. But the point is that when we want to extend channels and go another level below what I've done so far, the way we do that is we apply a custom binding element somehow, and we can do that in configuration or in code. And that custom binding element is responsible for creating either the client factory channel or the server channel listener, which means you have ultimate control over every aspect of that. So to sort of come back to the slides here then, when we talk about doing custom channels, which you could do more than a whole hour just on that, we're talking about building something that basically comprises binding elements, possible custom binding elements. And, like I said, when you create a custom binding element, what you can do is add it to an existing binding, like you can change TCP channel to add your feature, or you can create a completely new binding, which you custom build. You do that, some of the essentials here: extend the binding element type, and then that is responsible for constructing the channel factory or listener. On the client side, you create a custom channel factory, which builds the channel. On the service side, you create a custom channel listener, which builds the channel. They should be equivalent on both sides, so usually this code needs to be shared. And just to give you an extremely quick demo of one example that's, again, very popular, and this comes with the SDK, so I want to make sure you know that you can get this, is it's a chunking channel. And essentially, this chunking channel has a chunking binding element that takes a message and breaks it up into parts. So this chunking binding element here is basically responsible for, if we take a look just down here, creating the chunking channel factory for outgoing messages, and then, of course, building the channel listener for incoming messages. So if we take a look down here, you'll see somewhere the logic for building the channel listener here. And what that will do is, again, control how messages happen between the client and the service. So as far as the client's concerned, it's actually just going to send a single image. And I'm just going to run this, actually. Oh, sorry, it's gotten rid of the startup project defaults here. So what we'll do is we'll start the client, start the service, and repeat this. So on the client side, and I'm actually just going to run this for a sec so that this is a little faster. Okay, so press enter. Now the service is available. So on the client side, all we really want to do is, create our proxy, but notice it's creating a new instance of the TCP chunking binding. So it's actually wrapped up in a class, and it's going to have all that control low level for all the custom binding elements that were involved, in which case it's the chunking binding element. Now, if we kind of step into this, after we create the channel, what happens is the chunking channel factory is created, and it provides the information necessary. For example, how many buffer chunks do we allow, and so forth. And then, of course, on the server, let me just continue. When we call, what's going to happen is echo stream will pass a single message. So as far as we know, only one message gets sent. But check out what happens on the server. We're going to process chunks as they are received. 1, 2, 3, 4. So the client has broken up the chunks into parts and sent them in separate messages. But we don't really see that on the client because it's happening at the low-level binding. And so you can see here that we received and echoed back each of those chunks in parts of 10. Now, the details of that, obviously there's a lot of business logic involved that you want to take a look at. This is a very popular example of a custom channel. And the reasons for extending for a custom channel are really, again, at that point what you're saying is, I want to insert some functionality that I cannot achieve with the other extensions. And so I'm going to create a custom channel that maybe, hard codes the use of HTTP a certain way with, MTOM, with chunking behavior that we can turn on and off. And you can just wrap all that up into a nice little feature that you can configure in the binding configuration section. And so there's a lot of value to that, but of course it's a very in-depth process to build a custom channel. Another reason would be to do custom protocols like UDP or SMTP, and there are examples out there that already do that. So you would take existing samples and kind of work with that as a starting point. Okay, so I've given you a lot of different examples here of different mechanisms for hooking into the extensibility environment. And at this point, because we're in a series of 15 and we just finished, I want to thank everyone for participating, because I know a lot of you came to a lot of these webcasts. And, like as always, if you want to send me any questions by email, that's fine. All the sample code is currently part of either the book download, which is on indigogirl.net, or I'm about to make a post that includes my extensibility examples that I just showed you. If you need a refresher on all the webcasts that were available, remember DOS Blonde has a list of all these guys that you're seeing on this slide. And so that's the topics that we've talked about in the past couple of months. Please feel free to replay them anytime. And with that, again, I just want to thank everyone for participating and remind you where to go and get the code, indigogirl.com, for all the samples that I've shown. And I guess I'll return the floor back to Sarah, and thanks again.
All right. Thanks so much, Michelle. It looks like we've got, let's see, one question in there. So if you guys have any questions for Michelle, go ahead and type those in now. And while we're doing that, I'm also going to be putting a survey up there. To print a copy of today's PowerPoint, just simply go up to File and click Print to PDF. And to view a replay of today's live event or to register for upcoming webcasts, visit Microsoft.com/webcast. So bear with me one sec while we put the survey up there, and just click on the link provided in your interface. Fill out the survey and give Michelle the great feedback that she deserves. And I'm going to hand it back over to you, Michelle, to start answering the questions.
Okay. There is one question in here. Apart from IIS and WAS, where can we host, deploy services, and how? Okay, so I did talk about this in my hosting webcast, and essentially you prefer IIS for HTTP today on Windows 2003 server. We want the WAS, though, because that will give you TCP, name pipes, MSMQ, any protocol hosted in an environment that is highly available, that has health monitoring built in and pooling and all of those good things. So basically, you prefer the IIS and WAS. Now, aside from that, on a server machine today, you might use a Windows service to get around the limitation of IIS that you cannot host TCP, name pipe, or MSMQ services. So Windows service is good for the server side. On the client side, you might use a Windows application if you are hosting services tied to a UI, and that's a viable option. Console is good for testing. And in terms of how to do that hosting, I have numerous examples, actually. Look at my hosting directory. It's got all kinds of different examples of hosting. And, of course, there are some labs in my book that walk you through the different mechanisms. So if you have a question, can you send it by email? Yes, you may send me questions by email. Sometimes I'm on the road and quite busy, and if I can't get to it right away, you'll have to understand that. I even don't mind if you send the question twice in case it gets buried in the junk mail folder or something. You never know. Email is not all that reliable, but I do try to answer everybody, even if it's just to say, hey, I can't get to this right now. So feel free. And a question that was asked here, can I explain the difference between event handler and routed event handler? I'm not exactly sure what you're referring to here. I don't think that's related to what I just talked about, but you might want to clarify that. In terms of the second part of your question, you cannot exactly get the practical usage of extensibility in a real application. Well, actually, there's a lot of real value to extensibility. In an environment where you're building services, usually, WCF has a lot of configuration options, and usually you've got a certain set of things that you're going to do for all of your services. You might have standards. We always use error handlers this way. We always use throttling behaviors this way. This is the way we secure our services. I would like to extend the environment so that we inspect parameters in this case, and we wrap up some functionality that's reusable. Instead of littering your code in your business logic or in the operations of the service with all kinds of custom stuff, putting these things in extensibility components allows you to make it reusable, so that it's just a piece of code that you flip on the services that you want to use it. So it's extremely valuable, actually. Okay, so I don't see any other questions at the moment, but I guess just feel free to email if you do have extended questions, and we'll take it from there.
All right. Well, thanks, Michelle, for the great webcast, and thanks to everyone for joining us on this early Friday morning. Have a great afternoon and a great weekend. That concludes the audio portion of this webcast.